Hey, it's Dr. J. 6.4, talking about money, in particular simple interest. So interest is applied to loans and investments. We like to say that if you don't charge interest, or if one does not charge interest on a loan or doesn't receive interest on an investment, it's not interesting. There's nothing interesting about the problem. Without interest, then if you borrowed $100, well, then you would just simply pay back $100, and that math problem is really not very interesting. And conversely, if you were an investor, trying to make money, and you invested $100, and then, after some period of time, you just get back your $100, that you haven't made any money. And again, that's not very interesting. It doesn't make for an application or a math problem that we would be interested in solving. Now, in this section, I will use only the simple interest formula. There is a more complicated interest formula that you'll probably learn in your next class called compound interest. We're almost at the end of the semester here, so I'm just going to keep it simple. Okay, so when you borrow or invest money, the original amount is called the principal. Now, for years I spelled this word wrong. It's not principal with a PLE. That would be a different form of the word principle. That would be something that you believe in, or some kind of a philosophy, or a principle, a truth that you hold to be true. A principal is kind of like the boss, or the original, number one. Yeah, the boss. That's why we call the boss of the school the principal. So whenever we invest an original amount of money, we will use the variable P. Okay. Now, the interest rate is typically a percentage. R%, we use R for interest rate, and I think I mentioned this before. We use P for principal, and so we can't use P for percent, so we have to pick another variable for percent, so we use R%. In all of the applications, we convert this to a decimal. So be careful with that, because you're going to get a problem that'll say like 5%, and then if you actually use 5, then that wouldn't work correctly. You'd have to use 0.05 or whatever, the 0.05, which is the decimal version of 5%, for example. And then the interest, we use T for time. It's usually years, but we should read carefully. So there might be some problems that use years. Most of them do, but occasionally we'll throw a stinger in there where we'll switch it to months or days or weeks or something like that. And so the general formula is interest is principal multiplied by rate multiplied by time. Interest is principal times rate times time. And so the formula, algebraically, we'll use the variable I for interest, P for principal, usually a lowercase r for rate, and a lowercase t for time. And then if you really want to emphasize the multiplication, you can put the dots here, but the dots are optional, as I've been saying for months. Okay. So we'll go ahead and get started. We'll start off with a very simple example. So this is the amount of interest in addition to the original principal. So for the first example, I'm just going to show you how to calculate the interest. It's relatively straightforward. The same formula is used for investing or borrowing. So suppose you borrow $500 at 6% annual interest. For 3 years. How much interest is the interest on this loan? So it is in years. We do want to make sure that these match. So it says 6% annual interest and 3 years. Right? Annual means per year. So that's very important. You want to make sure that the interest rate and the amount of time should be the same unit of time. So they're both years, annual and years. Right? Annum. Sometimes it'll say per annum. So the amount of interest on this loan is the principal. I'm just kind of working up here because I've already got my formula. The principal is $500 multiplied by the interest rate, which is 0.06. If you want to clean up the decimal dots so you don't have dots and other dots that make it confusing, I'll just use parentheses instead of dots. So 6% is R, which you have to write as a decimal. I'm not going to go into how to convert it to a decimal. You know how to do that from the previous sections. And then the number of years is the time. So that's 3 years. Highly recommend using a calculator for these. So you've got $500 multiplied by 0.06 multiplied by 3. And so that's $90. Now remember, that's just the amount of interest, right? That's just the amount of interest. That's not the total amount. The total amount is actually $590, but this question is just asking for how much interest is paid. Okay. Let's do a couple of these before we move on to the more complicated ones. Just want to get familiar with this formula here. Okay, so there you go. I guess we'll do another one. We're going to do a lot of these today. So example 2. Suppose you invest $900 at 2% annual interest. How much interest is earned after 18 months? So this is kind of the other side of the coin. Instead of borrowing the money, you're investing the money, which is kind of the bright side. Keep in mind that every time you borrow money, somebody else is on the other side of that loan. It might not be a person, it might be a company or a group of people or what have you, but there is an entity there that is investing in you every time you borrow money, and vice versa. When you invest money, usually on the other end of that, it's somehow somebody else's problem, right? One person gathers what another one spills. Okay, now we have to be a little bit careful here. So it is 2% annual interest. So I do have the R is 0.02. That's fine, yeah, annual. However, 18 months is not annual. So you need to divide by 12 to get your t. Because 18 months is not, you don't want to put 18 as t. It's 18 divided by 12. And I don't think I need to explain why, because there's 12 months in a year. Sometimes this comes out to be a very nice decimal. I don't even need my calculator for that. That's 1.5. But just to be safe, 18 divided by 12, and you can see it's 1.5. Caution, if you get a repeating decimal or if you get a long decimal that fills up your calculator, then don't write it as a decimal. Keep as a fraction. Keep as fraction if the decimal does not terminate. I don't know if I have room to write the word terminate here. So if you don't get a nice terminating decimal, I don't know if you can see that, it's down there at the bottom, but if you don't get a nice terminating decimal like 1.5, then just keep it as a fraction, because as soon as you start rounding and things like that, it causes all sorts of errors. Okay, so you got your interest rate, you got your time, which is 1.5, and then you got your principal, which is $900. So how much interest is earned? I equals 900 times 0.02 times 1.5. Nice thing about multiplication is you can do that in any order you like. So I actually multiplied it backwards. I went 1.5 times 0.02 and then times 900. And I got a whopping $27. Woohoo! Okay, so it's kind of like this. You put the $900 away, in an investment, and then you can't touch the $900, and then a year and a half later, you get a check for 27 bucks. Yeah? And keep in mind, you still have the 900 bucks, right? The 900 bucks is just kind of sitting there in the account, right? Or in the investment account. And again, if it was a loan, that's the other side. After a year and a half, your $900 loan, you now owe an additional $27 on top of the loan. Now, sometimes you can flip this around. Suppose you already know how much interest you're getting, but you don't know something else. You don't know the time, or you don't know the rate or something. So I'm going to do the same thing I do with all of these application problems. I set up the basic recipe, and then I sort of mess around with the unknown values and maybe have you solve for something that we didn't solve for last time. So suppose your bank charges $620 in interest for a 2-year loan of $2,700. Sorry, I read that backwards. $7,200. What is the interest rate? What is the interest rate? Okay, so your bank charges $620 in interest, so that's actually your I. That's your interest rate. The original loan was P, that's your principal, and the R is the unknown value. So you're going to have 620 equals, and time, don't forget time. Time is T, 2 years. So it's $7,200 times R times 2. Okay, now look how R looks kind of stuck, sandwiched between them. And so remember, multiplication is commutative. You can rearrange the order and get the same values. So what we're going to do is we're going to use the commutative property we're going to change the order here, 7,200 times 2, and then R. This is called commuting. Yeah, to change the order. Oh, I could do that in my head. Can I? 14,400. 7,200 times 2. It is kind of early, so make sure I'm doing it right. 1440. All right. And then now we're solving for R. So we're going to divide both sides by 1440. 14,004. I keep saying 1440. You know what I mean. 14,400. Cross those off. I can't do that in my head. So I'll use the calculator. $620 divided by $14,400. So R is, now I switch sides. Technically it reads this way. Here, why don't I write it exactly the way it reads? The R is on the right-hand side, and then the answer is 0.04305. Let's round to 1 decimal place. So that's going to be, we're going to move it over 2 places to the right, turn it back into a percent, 4.3%. And we can just round, so the dictator here is actually the 0. Throw away the 5, 0, also throw that away. And so you just have 0.043, turn it back into a percent, you get 4.3%. Which is pretty good. Yeah, it's not bad. It's not as bad as some of those emergency loan places. You know, if you go to one of those emergency loan places and you borrow money for a, call this a payday loan. Now, it might seem cheap at first, you know. I've done these when I was young and broke. Payday loan charges $50 for a 1-month loan. Of $300. Yeah. What is the annual interest rate? So it's kind of the same question. I'm asking for the interest rate. But these are these short-term loans. So it's like a month, and it seems like a good deal, right? You borrow $300 so you can pay your bills. So that's your principal. The interest seems small, you know. Oh, I only have to pay $50. I'll do that. But let's consider how much you're actually paying in interest, right? Annual interest rate. So remember, annual is years, and months are months. So T is 1 month divided by 12. Yeah. Now watch what happens. When you go 1 divided by 12, look what you get. 0.08333333333. Right, and so if you try to type this into the problem, it's probably going to cause a little bit of an error. So I'm going to keep this as a fraction because the decimal does not terminate. So I'm going to say the interest is $50. The principal is $300. The interest rate is unknown. And the time is 1/12. So you have I, if you like to put your formula here so you can keep track of everybody. So you have I equals PRT. All right, and then similarly, I can combine these guys or rearrange them. So I have 300 times 1/12 and then times R. Last time I solved this type of problem, I just kept it backwards. This is a little trick I like to do, and I might start doing this more often. Just flip it around. So the 300 By the way, 300 over 1 and then 1 over 12, you can just multiply straight across. So that's 300 twelfths. R equals 50. You can try to reduce that. Let's see, they're both divisible by, let's see, is 300 divisible by 6? Yeah, it is. So 300 divided by 6 is 50. Oh, actually, 300 is divisible by 12, isn't that? Might as well just go all the way. Perfect. You get 25R equals 50. I was trying to reduce 300 over 12. But before you do all that fancy fraction stuff that we learned back in chapter, what was that on? It's been so long, chapter 4 or something. If you get a nice divisor where it's divisible, 300 divided by 12 is 25, you might as well just do it, right? But if it's not divisible, then I would recommend reducing it. And then now you're going to divide by 25, and you're going to get R is 2. I don't know if you can see that. R is 2. The camera's really in a weird angle today. All right, so what is the interest rate? Be careful. It's not 2%. R is 2. Now be careful. It's 2 converted into a percentage. And remember, any number bigger than 1 is going to be more than 100%. So in particular, 2 is 200%. So keep in mind that when you solve for R, this actually means multiplied by 100 to turn it into a percent. Now, typically, I do this multiplying in my head, although back in the beginning of the percentage lectures, I was showing all the steps on how to convert from a whole number or a decimal, doesn't matter, any value that's not a percent. To turn it into a percent, you multiply by 100. To turn it back, you divide by 100. Yeah. So that's the answer, 200%, which is not good. Yeah, 200% interest. So they often make these loans sound appealing and sound like a good deal. Oh yeah, it sounds like a great deal. $50, no big deal, right? I need the money now. I got to pay the bills, right? But the amount of interest that you're actually paying is 200%, which is, we call that astronomical, essentially. Okay. The last thing before we move on to the more complicated version is, suppose you forgot or you just didn't document, maybe you spent the money, how much you originally borrowed. Yeah. Or invested. So you put it in an account. It could be an investment. It could just be a savings account. It could be some sort of dividend or mutual fund, or there's all sorts of ways to. There's like any way you want to put your money in something. There's some place out there you could put your money. So suppose it earns 4.4% annual interest. And then 3 years later, you receive a payment of $118.80. Yeah. Now, when you're doing these financial math problems, whenever the cents end in a 0, it typically doesn't put it, so there's an invisible 0 right there. So that's $118.80. Yeah. So this 0 is often invisible. I've never seen that at a store, right? I've never seen an item on sale at a store that says, $118.8 without the 0. But in math, we often do that. We often omit that 0. All right. How much did you originally invest? And now you've seen all the different variations of the problem. So the unknown value now is P. Let's make sure everything is in terms of years. Yeah, annual interest. Okay, good. That's 3 years. Good. Check. So that means that this is T and then this is R. And we don't have to do any, dividing by 12 or anything like that. All right. So remember, the interest is equal to principal times rate times time. And I'll just give you a hint. If you know that you're going to be solving for either P or R or possibly T, then you might as well just put those on the left-hand side. This is the mirror image of the formula that I wrote down in example 1. Right? Sometimes it's nice to look in the mirror image and say, oh, I might as well solve it that way. So now we know P is what we're solving for. So let's just leave P as P. Now be careful with R, right? R is not 4.4, it's 4.4 divided by 100, which is 0.044. So that's your R. Sometimes I feel like when I say, convert the percentage into a decimal, and then that sticks in your head, convert it into a decimal, and then when I give you a problem that's already a decimal, sometimes the little voice in the head says, well, this is already a decimal, so I'm just going to use 4.4. So maybe a proper way to say it is convert the percentage into a non-percentage. So this is no longer a percentage. This is 0.044. It's now a true decimal. No more percentage. And then the time is clearly 3 years. And the interest was, how much was the payment? That's your I. That's I. So that's 118.8. And I'm going to go ahead and omit the 0. All right, 0.044 times 3 first. It's going to give me P times 0.132. And it really doesn't matter what side I put the P on. Yeah, I could put the P on the left or the right. It's the same thing. You're multiplying. So I'm just going to divide and get rid of the decimal so that I have the P isolated. All right, and that's it. The whole thing is done in that one step. Or if you like to think of it as 2 steps. 118.8 divided by 0.132 is equal to 900. So how much was originally invested? $900. That's the P. That's actually not so bad, right? I mean, if you got an extra $900 that you don't need. Now remember, you don't actually, this $900 is still sitting there, right? It's going to work every day and earning more interest and earning more interest. And this is now we usually refer to this as a dividend, right? You're receiving dividends. Some really financially savvy people that don't need the $118, suppose you don't need that extra, you could just put it right back into the 900. Now you've got over $1,000. Yeah, and the money goes back to work for you, and a couple years later it earns even more, and so on and so forth. The wheels go round and round. All right, so now we have to start talking about the total amount. All right. In other words, I want to start combining the principal and the interest, these two values together, and putting them together and saying, what's that total amount? So the total is called A. All right. And again, we don't want to use T for total. All right. We want to use A. It's just because we've already used T for something else, right? We've used T for time, and we've also used T for tax. And so with variable letters, you have to be really careful about what you call them. The total is the original principal plus the interest. That's the total. You add the P and the I. And then if you remember, it's only been a couple minutes, so I'm sure you remember, that I is PRT. Okay, this is sometimes called the amortization. It's a fancy way of saying how much is in the account or how much is owed after some period of time. You could also just say after. Yeah? After some period of time, this is the total amount that I have in my account. If it's an investment. If it's a loan, then this is the total amount that you owe. I should mention that before I get into the next example, that this is simple interest, so there is no compounding, there's no monthly fees, there's no penalties for late payments. This is also assuming that you're actually not making monthly payments. So this is a very simplistic way of looking at it, but it's a good, effective way of looking at it. It gives you a rough idea of how this actually works. And then when you want to get more into the business calculations and the more advanced, like you would use in an accounting situation, then this formula gets a little bit more complicated. But that's not going to happen this semester. Okay, so let's go ahead and use this formula. Example 6. I want to keep the formula here, so I'm going to try and squeeze my problem here. Suppose you borrow $6,000 at 5% annual interest. Sometimes we'll say simple annual interest just to make it clear, but since all the problems I'm doing are simple, let's just keep it that way. For 7 years. Did I say 6 years? I meant to say 7 years. So $6,000 at 5% interest for 7 years. How much is owed at the end? And again, nobody's ever going to do this. Nobody's ever going to loan you $6,000 and say, hey, just in 7 years, come back and pay us. That's typically not the way it works, right? You've all know how this works, right? They're going to want their money the very next month, and that's where it starts to get more complicated. So this is a very idealized way of thinking about it, but it still works. It works pretty good. So if you go and you want to buy a car and they're telling you that there's an interest rate and how much the car costs, and you're going to be paying it off for 7 years. This gives you a pretty good idea. It's not exact. Again, it's simple, but it gives you a rough idea about how much you'll end up paying for the car or whatever it happens to be. It's a pretty cheap car, $6,000. Okay, so how much is owed? That's A. Yeah. Our principal is $6,000. Make sure everything matches. Annual, years, annual, per annum, years. So 5%, that's going to be 0.05. So that's going to be T. That's going to be R. And away we go. So we got $6,000 times 0.05. Oh, excuse me, I almost screwed it up. $6,000 plus another $6,000 times 0.05 times 7. Don't forget now, we're asking for the total, how much is owed, including the original principal. So there's your original principal. I'll annotate it up here. P and then PRT. P plus PRT. P and plus PRT. It's the same formula here, so now I can erase it. Now make sure you don't add the 6,000s. Do the interest first. All right, that's your I. I'm not actually going to write the letter I, but this is I here. So we got $6,000 times 0.05 times 7 years, $2,100 in interest, plus the original $6,000, so that's $8,100, or with a dollar sign, $8,100. And if you really want to be fancy, it's $8,100.00. Some of the problems will actually end up generating cents. If they do, then you have to put the cents. If they don't, you can leave them off and it would still be correct. But if you really want to make it look like money, it's $8,100.00. Okay. So that's simple interest. The only thing I could do to make it complicated, because that's what we do, right? We give you a simple recipe, and then to really dive into it and to really sort of, get the most that we can out of it, we change some of the terminology or we throw in some other variables and things like that. Actually, I'm not going to include any other variables, but I'm going to include some other verbiage and terminology. Suppose you invest, I just keep trying to alternate between investing and borrowing. Suppose you invest, $25,000 at 3% annual interest. How much is the total after 4 months? All right, how much is the total after 4 months? Again, the total. So the total amount, including the original $25,000. I will try to make that clear in the question, whether I'm asking just for the interest or whether I'm asking for the total amount. All right, so suppose you're being impatient. You're like, okay, I put this $25,000 in this account. It's earning me 3% every year. 4 months later, I really want to know how much I owe. Well, 4 months, T is 4 twelfths, because there's 12 months to a year. All right, and I'm sure that that's not necessary to tell you that. You already know that. So this is 1/3 of a year. So this is the same as saying, how much is owed after 1/3 of a year? And then your interest rate is 0.03 and your principal is P. Oh, not how much is owed, how much is in your investment account, but I guess that's the same idea. So you've got your original P, $25,000. I usually omit the comma because it's unnecessary. Then you got your $25,000 times your interest rate times your time, which is 1/3. And again, the reason why I'm keeping this as a fraction and not a decimal is because you all know that 1/3 is 0.333333333, so we don't want that would make things really messy. Okay, so how much, I'm checking online, how much do I have in my account now, including the original? So I've got $25,000 plus, this is how much interest I've earned, $25,000 times 0.03, and then times 1/3, or you could just say divided by 3 means the same thing, $250. Oh, I love it when that happens. It comes out perfect. If it doesn't come out perfect, you get some decimals, then I want you to keep 2 decimal places for the cents. Yeah. So that's $25,250. Woohoo! Yeah. So be patient, right? I wouldn't check on this account very often because it's just going to slowly grow. You come back in 20 years and this will probably have a lot more money in it. And again, these are dollars, yeah? So this is $25,000.00. Oh, 25,000. Oh, I almost screwed up. $25,250.00. There we go. All right. Let's go back to borrowing. Suppose you borrow $4,000 at 13% annual interest. How much is owed? How much is owed after 20 months? So you borrow $4,000. It's kind of a high interest rate, 13%. So you can kind of use some just common sense math, about whether it's going to be a lot or a little, or just to give you some idea. That way, if you make some calculation error, which I often do, you can give it kind of a head check and say, well, does that make any sense? If it's a high interest rate and you end up with a lot, you end up owing a lot, that could be important. So your principal is $4,000. Your interest rate is 0.13, 13%, or 13 divided by 100. And then be careful again, 20 months, that's not years, so that's 20 divided by 12. Now, I think 20 divided by 12 terminates. No, it doesn't. I thought wrong. Yeah, so this is a repeating decimal, so I'm just going to go ahead and keep it as 20 divided by 12. Or you could reduce it. They're both divisible by 2. They're both divisible by 4. So 20 divided by 4 is 5. 12 divided by 4 is 3. So I'm going to keep my t as a fraction. Okay, and again, you probably could get away with using 1.66666 as long as you put enough sixes. But just to be safe, I don't want to be off by 1 penny or even a whole dollar and somehow get it wrong. So the amount that I now owe, and again, this is idealized. There's no monthly payments. There's no fees. There's no, late payments. This is just as if 20 months later, that's a weird amount of time, but it's almost 2 years. Now you owe this money. So $4,000 plus $4,000 again times 13% times 5/3. Okay, I'm just keeping my work over here. So $4,000 plus, let's go ahead and calculate the interest. 4,000. Make sure you clear out every time. I've accidentally done these problems and I kept an old number from a previous calculation. It screwed everything all up. Times 13%. Oh, I just did it again. $4,000 times 13%. So that comes out to $520. Oh, and then times 5/3. Now to times 5/3, watch the way I do it. It's 520. That's just these two done. Then I'm going to times them by 5. And then I'm going to divide by 3. Now there are various ways to do this, but I don't want to have any, calculator error. All right, that's one of the problems with calculators is they cause error. It's weird because you would think a calculator would be very, very precise, but calculators can cause lots of issues if you're not careful with them. So it's 520 times 5, so that gives me 2,600, and then divided by 3, and there's my repeating decimal. Yeah. And remember, I want 2 decimal places, so this is going to be $4,866. And then I'm going to look at the 3rd decimal place. If that's bigger than 5, I'm going to plus 1 to the 6, cross these guys out, and that's going to be 67 cents. That's kind of a lot. It's like you're paying an extra $866, and it hasn't even been 2 years yet. It's only been 20 months. So keep that in mind when you're borrowing money. It'll happen. Okay. This is going to be a relatively short lesson. It only has this one topic. I can't say the same for the next section in the book, which is probably going to be the end. But why don't I just go ahead and do a couple more? There is a thing called monthly interest. Suppose you borrow. Monthly interest is usually with loans. $500 at 9% monthly interest. So it's no longer annual interest. It would be as if you were treating 1 month like a year. Yeah, so every month in this example acts like a year. How much is owed after 2 years? All right. So now it's 9% monthly, but the amount of time is in years. And so you can't solve the problem this way. The interest rate and the time have to be of the same unit, right? So you either have to turn 2 years into months, or you have to turn months into years. I think it's easier just to turn 2 years into months, right? Multiply by 12. You could probably just do that in your head. Right? 2 years is 24 months. All right. And now you've got your monthly interest rate and you've got your monthly time. So the amount that would be owed would be the original $500 plus $500 times 9%. Remember, 9% decimal, and then times 24 months. Again, you have to make the time and the interest rate match in units. What are they measuring? So this is measuring months. And again, I have seen a very, very, very good students that were doing very, very good job in this class will make very, very simple mistakes like adding the 500s. If you add those 500s and you get 1,000, the whole thing is wrong at that point. So just ignore this, figure all of this out first. I know I say this a lot, but I've seen this movie several times and I know how it ends. So $500 times 9% and then times 24 months. Oh my goodness. Look at that. This is how they get you. If I can teach you one thing, it's that you never know, right? I mean, until you know. 9% doesn't, it's high, right? 9% is high, but it's not that high. It's not like those payday loan places. Those payday loan places are like 200% interest when you go to get quick money to pay your rent or pay your electric bill or something, right? But so they can kind of fool you, right? This is like, who does this? You know who does this? You ever heard of that Aaron's Brothers, the company that rents furniture and refrigerators and televisions and things? If you need something and you don't have the money, they'll tell you this. They'll be like, no problem, come on in. We have a very low interest rate. Yeah? We'll sell you a $500 television and it's only going to be 9% monthly, 9% every month. Yeah, and you'll have the loan paid off after 2 years. So after 2 years, you own that television. And they make it sound like it's such a good deal, right? They might even tell you that you only need to pay $20 a month for the television. But look how much you end up paying. And so if I can teach you anything, it's that you need to know what you're getting into. And I'm a mathematician. I've got a PhD in math, and I've fallen for this trick before, right? Desperate times call for desperate measures. And you really got to have that TV, or you really got to have that refrigerator, or you really got to have that new couch. But this is how much you're going to end up paying for that new couch or that new television. $1,580, and there again is no cents. Right? But you could just say $1,580. I get it. It's $1,580 for what you thought was a $500 television, or whatever it was that you needed. When this happened to me, it was a refrigerator. Yeah, my refrigerator broke. I needed a new refrigerator. I saw the commercial. Come on down, 9%, no problem. You end up paying this much by the time it's all said and done. So that's one thing that math's good for. It's good for educating us, and sometimes the lessons are hard learned. I never learned my lessons. I don't take good advice either. But I hope you will. All right, almost done. Pretty painless lesson, right? I mean, most of it is just about learning the lesson, not really complicated mathematics here, just understanding what you're getting yourself into. So let me do maybe one more. I don't know, maybe two more. We'll see how the next one goes. So example 10. Maybe I can get this done in under an hour. I've been trying to do that for you guys lately because I know you're all probably tired of being on the internet all the time, and you're all zoomed out and YouTubed out, right? Suppose you borrowed. I'm just getting stuck on the borrowing now. Unfortunately, on this side of the fence, we are more likely to be borrowing money than we are to be investing money. Suppose you borrowed, suppose 2 years ago, let's make it 4 years ago. I'm getting tired of 2 years. Suppose 4 years ago, you borrowed some money at 8.05% annual interest. All right. If there's no penalties, no late fees, etc., etc. I don't want to write out all the things. Basically, there's no extra stuff added onto it. You owe, all right, so it was 4 years ago. You now owe how much do you owe now? $1,776.50. Again, 50 cents would look like that if you want to write it as money, but I'm just going to write it like that. Okay? How much did you originally borrow? I mean, this might have happened. It's happened to me. It's like, I can't remember how much I originally borrowed. But they keep sending me this thing saying that I owe $1,700 for something happened 4 years ago. I don't remember. What happened? How much did I borrow? Was it $100? Was it $500? So I want to reverse this process and solve for P. So P is the unknown value. A is the known value. R is the interest rate, and T is the time, and everybody matches 4 years, 8% annual interest, so everything's matching up. I got my A equals P plus PRT. Now I only do this trick, and I think I mentioned this technique in the last lecture, at least I hope I did. I'm pretty sure I did. When you are solving for P, and you've got more than one P in the problem, you want to put an invisible 1 here. Yeah? An invisible 1, so this is 1P. Right? This is 1P, and this is RTP. Yeah? That's how many P's there are. And you can combine the 1 and the RT, and then write the P one time on the outside. There's a technical name for this. We call this factoring out the GCF. Now you're going to learn an entire section, probably an entire chapter on this next semester. So I'm just giving you a quick preview of how this works. If you have the same variable occurring twice, then you can use parentheses and take that variable outside, and we call that the common factor is P, because that's what I'm trying to solve for. So I don't want to have there 2 P's. I just want there to be 1 P. Okay, so let me just erase some of this stuff. So I've got 17, I'm just moving up here. A is 1776. 1 plus RT. So R is, now be careful, R is actually 0.0805. Remember, you got to divide that by 100 to move the decimal over. So 0.0805 times T. Let me just make sure everything's clear. So I've got the A, that's clear. I've got the 1, I've got the R, and then now I got the T. I'm just going to put the T in a little baby set of parentheses here. The T is 4 years. Okay. Oh, and then don't forget the unknown variable is P. I almost lost I looked at it and I'm like, where'd my P go? So there's your P. You want to solve for P. Okay. Do everything that's in the parentheses first. So you've got 0.0805 times 4. All right. So that's 0.322. I know I'm working up instead of down. It's probably not the best habit, but I hope you can handle it. And then now add these together. You're going to get 1776.5 equals 1 point. So the 0 adds with the 1. So it's 1.322 and then P. All right, now I've literally run out of room, so I'm driving you guys nuts, I bet. So now I'm coming back down here. So now I've got 1776.5 equals 1.322 P. I don't need the parentheses anymore. And now I'm going to divide by 1.322. Okay. I probably should have been working this direction altogether, but I mean, it's okay. This is scratch paper anyway, right? I'm crossing this out, I get P, and then now I use the calculator. You really only need the calculator maybe 1 or 2 times in the entire problem. 1776.5 divided by 1.322 is 1343.797. All right, and I only want 2 decimal places, so your dictator is going to make you round up 1. So that's going to be $1,343.80. That's your P. Right? The 7 rounds the 9 up to a 10, and then rounds the 7 up to an 8, and so that becomes 80 cents. Which is, again, why you have to be really careful with the decimals early on, because if you don't have these decimals correct in the very last step, then your rounding will be off by a little bit. And I don't want you to have to do the whole problem over again because you were off by a penny or so. Okay, it's just about an hour and I'm almost done. The last example, I do have one more, and that would be for those of you that are interested in planning for the future. If you're interested in planning for the future, you want to put aside some money. So suppose you want to have, I don't know, $20,000 for your child's first year at college in 18 years. All right, so suppose you're planning ahead. Now, again, this is only going to pay for 1 year of college, $20,000. At COD, you could probably get 3 or 4 years for $20,000. So suppose you just had a child and you're thinking, okay, I don't want my kid to suffer the way I suffered. I want to put away some money now. Okay. Now they have these special savings account. Your bank offers a special college savings of 8%. That's actually pretty good. Now, I looked into this once, and the real rate, unfortunately, is much lower. It's like 1 or maybe 2%. But I'm just trying to make things look a little rosy, end this on a high note, right? So you just had a child, right? Just had the child. I'm not counting months. I'm just counting years. So it's 18 years in the future, and you just want to make sure that when your kid goes off to college, they've got $20,000 to get them started, right? It's definitely not going to pay for the whole thing. In fact, I hate to tell you the even worse news. In 18 years, this $20,000 probably won't even pay for the first semester in college. So you better start saving now. How much should you put away now? So this is sometimes called future value. Yeah, future value. How much should you put away now is called present value. All right. Now, I don't have to teach you a new formula. It's exactly the same formula. Present value is P. That's what the money is worth right now. How much you would have to actually put into the bank now. Future value is A. So it's kind of like predicting the future without actually doing it, right? You can predict how much you would need now in order to make $20,000 in the future, all right? And then you got your T. Make sure everything matches. 8%. Again, I'm assuming it's annual. It should probably say that. 8% annually. And then T is 18 years. All right, so the formula is future value is 1 plus RT times the present value. All right, this is exactly the same formula we used in example 10. All right. Now here's what I'm going to do this time. I'm going to write all this stuff down, and then I'm going to work vertically top down, so I at least end this lesson with a little bit more organized set. So A is 20,000, R is 0.08, and T is 18 years. All right, so I just wrote all that down so I don't forget any of that stuff. Now I can erase all of this. So I've got $20,000. Oh, I almost wrote 2,000. 2,000 is barely going to pay for your books. So $20,000, 1 plus 0.08 times 18, and then times P. Work from the inside out, so do the parentheses first. 0.08 times 18. That's 1 plus 1.44. So that'll be 2.44p. You don't really need the parentheses anymore. Now, because this is 18 years, 8%, it goes over 100%, right? That's 1.44, so it's going to be much larger than it was in the last example, right? And then now you just divide by 2.44. So we got $20,000 divided by 2.44 is $8,196.72 or 7213 equals P. Again, look at the third decimal place. That's your dictator. It's less than 0, so you just throw them away. Do not round up. And so if you want to send your kid to college, at least with a little bit of help, and this would be a very good deal if you could get this deal, you'd say, okay, I can take this $8,000 that I have. I don't know. I mean, I don't have $8,000 laying around, but if you happen to have $8,196.72, you know, that you don't need for the next 18 years, you could put it in this special investment, right? And it'll just sit there for 18 years. And then when your kid goes off to college, you go, surprise, I've got $20,000 for you to start your first year of college and pay for your housing and your books and your food and whatever it is. And you'd be lucky if it lasted 1 year. I went to college for a very long time, and it is very expensive. In fact, I'm still paying for it to this very day. But I'm glad I could help some of you achieve your goals. And I'm glad we're done. So until we meet again, this is Dr. Jordan. I'll see you on the internet.